One is I'm representing the Broadband Forum, so I've done some V6 work there on their RGs. I'm the editor of a V6 a draft in the IETF on basic IPv6 requirements for CE routers. I'm mainly going to talk about the CPE or the RG or the home gateway or whatever people have chosen to call it. Every standards forum has a different name for it. But it also applies to the home network. I also have another hat, which is where I have perhaps most passion and enthusiasm, and that's the user hat. I'm a user in my home network. So every time I say things like, the host has to fix this, the intelligent has to be in the host, the network can't do it, it's the user hat on, not Cisco's hat. So I like, I figured out word clouds, and funnily enough, ITU showed up as the the biggest one here. Is done on word frequency when I took all the references from the IETF draft, the WT 124, which is from the Broadband Forum, and the eRouter spec from Cable Labs. So these are basically the specs you need to implement if you want to do a CPE. Quite a few. And one thing to notice is that with these three specs I mentioned are, they're basically covering all, the most of the access networks, and they're old specs, and we're really just we're simplifying CPE vendors' work here by trying to make, a simple overview spec. This is how you can do a CPE. And giving the references where to go and look if you have to look for details. We're doing tinkering. You could do a V6 CPE 10 years ago. So please don't blame us for delaying V6 deployment just because we haven't done these specs yet. The Broadband Forum is, so a lot of the, these three specs I'm talking about are overlapping. And that's probably because they address different audiences. The Broadband Forum is made up of service providers and vendors, where service providers are really the ones deciding the agenda. And therefore managed devices, where the service provider is managing the device, typically with a protocol called TR69, which is also defined by the Broadband Forum. The IETF effort, which I think Fred Baker just sent off to the IESG, so that will be an RFC very soon, is made up of, the design team was actually people from the Broadband Forum and from Cable Labs and from the IETF, trying to find some common ground. So we avoided having a Cable Lab CPE and a Broadband Forum CPE and then an IETF CPE, which you could buy from Best Buy. So that's really the least common denominator for V6 support, because the way we did that work is, if anyone disagreed with something, we took it out of the spec. So it's very simple and it's very basic. By the way, if you did the word cloud slightly differently, where you put a space in between the RFC and the number, this is how the reference section looks like. So IETF is very dominant here for V6 support, and there's a little bit of IEEE and ITU specs you have to implement, but most of this is IETF work. I thought I should say something about the existing V4 architecture and what the implications are for the V6 work we've done. So lots of things have evolved over time in V4 space. So this is my home network. And yes, I did draw this picture myself, and it wasn't my 2-year-old son. So I have 3 isolated networks at home. I have the red one to the left there with the setup box. So that's a walled garden service from my ISP. It's realized as separate VLANs upstream. The RG bridges that traffic, and it gets address space, private address space in 10/8 from the ISP. There's no connectivity between that setup box or my TV and anything else in my network. So I can't, plug my camera in somewhere else in the network and look at pictures on my TV, for example. I get a VPN router from Cisco, which has a tunnel going straight into Cisco, giving me a Cisco address space in that bottom red link. And the blue one to the right there is NATed v4 space from my ISP. And if none of those spaces overlap, this kind of works okay. If my girlfriend wants to print something and I have a printer on the Cisco red link there, that doesn't work. If I have the printer on the blue network, I can't print while I'm working on Cisco stuff. So basically, and when I want to watch my porn or download, or whatever it is, I prefer to switch networks. So I have to, change plugs depending on what I do. And that's really not very nice. I mean, with my user hat on, I don't want my network to work this way. And so the VPN router could do split tunneling so that, only Cisco traffic would go to Cisco and everything else would go to the internet. But for that to work, to get return traffic done correctly, that VPN router would have to do NAT. It would be a basic part of the architecture, basic thing you needed for this to work. So how do we do this for v6? So what we do have is all these benefits you get from NAT that you don't necessarily get just with v6. You get stable addressing, you get some sort of multi-homing support, you get security, you get ability to plug and play routers, for example, with chain NATs, and you get also some sort of walled garden support, and the network hides all this from the hosts, which appear to be single home. So how do we do all of this with v6? So what we have said from a standards perspective is, well, let's ignore all that stuff because it's some hard choices to make. So this is the network we've, defined a profile for from the Broadband Forum perspective and from the IETF perspective. But that's really the network I want. I want my home network to look like this. And what I could accept, for example, if I have devices which don't do Ethernet, I could have a separate link for those, still with a single CPE doing everything for me. And so what we standardized is we said how the WAN link, the upstream link should work, how we do addressing. There are 3 models for addressing with Slack, the IPv6, or with what we call the unnumbered model, even though that doesn't exist in v6. On the LAN side, we're saying how you get DNS information. There's a DHCP server there for passing out DNS. We also accepted this RFC 5006 or the standard version of that when that's coming out. And the Broadband Forum has gone slightly further than the IETF draft to state how QoS should work, how multicast should work. We've said that simple security and firewall should be supported. We have tried very, very hard to avoid having to say something about if it should be default on or off. With my user hat on, I would definitely want it off because it breaks things. I really, really don't understand. And I've been working with networking for 10, 15 years. I don't understand what it does for me. So I really don't want it on. I actually don't want that VPN connection either. I just want to access my employer's data. Fine. I'm happy to do some sort of authentication, for example, but I could be on an application layer and not done on the network layer because that end up in all these separate isolated networks. We get all these problems with reaching local stuff and things. One thing to notice, though, is that even in this network, we are sort of multi-homed. And we're multi-homed in a term I used for this is non-congruent multi-homing, which is where you're multi-homed to 2 networks which, they don't overlap. give you access to different services. And even, in this case where you have a dual stack network, v4 and v6, the v6 and v4 networks don't overlap, as we know. So that's why we have the term non-congruent multi-homing. And that also applies with, those examples we had earlier today from NTT. If we have a walled garden service here, the VPN service, you still get every host being multi-homed. And the problem with that is that hosts aren't very good at multi-homing. Routers are built to do multi-homing, hosts aren't. So there's quite a bit of stuff which needs to be fixed there. And it's really just implementation details. It's nothing to do with standardization. It's just that they have to learn how to live and operate in this multi-homed environment. I've been thinking about, would we like the home network to be any more complex than this? Is there any point in having a rooted home network? I would plug in arbitrary number of routers here in my home network, and you could have loop topologies and what have you. And I'm still looking for a use case for that. It would be a fun problem to solve because we would have to have, both unicast and multicast routing in a home. We would, one requirement for a home network is that it has to be plug and play. You can't expect people to sit and configure OSPF areas, for example. So we would have to make that, plug and play. My problem, though, is that I can't find a use case for it. So we're probably not going to standardize that anytime soon. Other things we've specified here on the LAN side is the use of ULAs, unique local addressing. So a typical home network will have two v6 prefixes, one ULA prefix and one global prefix. The reason for that is to allow local communication to work, even though before you've been provisioned with a global address, or in the case of renumbering. For some reason, some ISPs want to continue v4 behavior so that prefixes are relatively short-lived. That's not something which works very well in v6, unfortunately. So, that would be like changing your telephone number on your phone during a call. That just doesn't fly. One other problem we haven't solved, which was mentioned, so just mention that before coming here, I was in Rio on holiday, and they mugged my watch, so I have no idea what the time is, and they mugged my glasses, so I can't see anything. But apart from that, I'm doing fine. Good. So non-congruent multi-homing, as I said, is this case where you're either v4, v6, or you're multi-prefix on v6. You get one prefix from your walled garden, one prefix from your internet provider, and the host has to choose the right one. And if it doesn't choose the right one, it fails. And working in Cisco, it would be nice to come up with a good way to do this in a network. And the best answer we have is NAT. You can do v6 NAT just like you do for v4, and it works. If we don't want to do NAT, we can send you ICMP messages saying you picked the wrong source address, perhaps, or we could do ILNP, or Dino is going to jump up and say, we can do Lisp. And yes, I think we can. Yeah, exactly. And this, yes. If we don't want to do it in a network, we need hosts to behave smarter with this, and we need to be able to do source address selection policy, DNS server selection policy, and things like that by the host. But the network will help you and distribute that policy down. And these are things we're looking at standardizing in the future, but it's not in the basic specs, neither from the Broadband Forum nor from the IETF. Another problem we're looking at is this multi-level NAT problem, where you get one RG CPE from your service provider. It doesn't do what you want, so you go and buy another one and you plug it in the back of it. And that kind of works for v4, sort of. If you don't have overlapping NAT, you make sure to buy RGs from a different vendor. Cross your fingers and stuff like that. But if we do that with v6, how do we do that? Because you don't have NAT. So you need some sort of hierarchical prefix delegation. You need some sort of default MLD proxy, passing DHCP other configuration options downstream. And if you want to solve this problem, do we also want to solve the problem of topology with a directed graph, or even a arbitrary topology with loops? And then we're back to a slightly more complex problem. So just to summarize on the unresolved problems, because they're much more interesting than the solved problems. Plug and play routing, if we need that. Hopefully the answer is no. Do we need to do flash renumbering? What happens if suddenly your link is down, you come up with a different v6 prefix, you're in trouble. This NAT kind of hides this from you, even though you lose all your NAT state for v4. What do we want to do with security? My answer with my user hat on is nothing. I don't want any security from my home gateway. But other people disagree. But what does security mean? I mean, could, for example, as Miyakawa-san suggested now during coffee, be that I had a firewall port on my RG, so I could plug things I didn't trust into that port and leave the remaining stuff open where I could actually offer services and use it. But I'd really like to see end-to-end compliant security, whatever that means. I mean, something which didn't break end-to-end connectivity. DNS, is the home gateway going to be an authoritative name server for your reverse zone, for example? Service discovery, well, that's been a great embarrassment to the IETF not having solved this problem for a decade. And again, multi-homing, QoS, multicast. QoS and multicast is something that Broadband Forum has specified. To some extent, it's an MLD proxy in their specification. So the basic specs are done. It's the working text 124i2 from the Broadband Forum. DOCSIS 3.0 has been there for a long, long time. The basic requirements for IPv6 routers are done. They're just making their way through the bureaucracy of the IETF. We're working on future stuff. The after basic is probably, it should be intermediate requirements for v6 routers, because I'm sure we're not getting to the advanced one yet. There's a BOF session on HomeGate again, which is an IETF effort looking at not only resolving the 6 issues on RGs, but also existing v4 issues. There's work that Dan Wing is talking about tomorrow, which is v6 NAT avoidance, which is again this non-congruent multi-homing. How can we avoid v6 NATs? And one thing to remember is that v6 doesn't change the internet architecture. So any problems you've solved in v4 and the way you solved it, you probably want to resolve it the same way with v6. But I really want to encourage people to think twice about these walled gardens, these VPN services, everything which is visible to me as a user in my home network and breaks things. I mean, I want to be able to print.
V6 restores the internet architecture.
V6 can restore the internet architecture, but please let it. Don't break it again. Yeah, thanks, Mark. Okay, any questions?
So we're gonna. Is it okay?
You're holding them to
yeah, we're gonna hold them to the end. We're gonna include questions for this part in the tail end when we're doing like 15 minutes or so questions. So thanks, Ole. Thank you very much. You can, if you want to stay up here with us. Yeah, whatever you want. Yep. Next we have Eric Vyncke from Cisco. He's going to talk about some of the security work that's happening from a standards point of view.
Discussed this morning. What about the security posture and the security policy in any CPE? Okay, I don't have the answer. I've got mostly questions on this, but let's have a look. So security questions first about IPv6 itself. So when you are adding IPv6, question number one, and I'm coming to IPv6 through the angle of IPv6 security, because I am a security person, basically. So question number one, is IPv6 more or less secure than IPv4? And we all know they are roughly equivalent. The only big issue is that until now, people know less about IPv6. And if you know less, of course, you cannot really secure your network, you cannot detect an attack, and this kind of stuff. And then, which security policy you need to apply for V6, right? This is only problem, this is everyone's problem. Must be the same as IPv4, including the NAT security. And we all know that every device behind the NAT has got a Trojan on it. It's part of a botnet. So I really wonder what is the security of NAT in this case. I must be blind or something, but anyway, I don't see it. Must it be the same? In 2000, when IPv4 CPE were developed, the landscape was different, and I shall come back on this. We are now in 2010, so things have changed, right? I'm getting older, I'm losing my hair, but CPEs are different. Other point, how much congruency do we need to have between the IPv4 security policy and the V6 one? And there, this is maybe where I personally disagree with some people in the room. They must be congruent because the end user has no clue about V4 and V6. He only knows about PC, networks, and device. So he doesn't care whether it's V4 or V6. It means that the security policy must be congruent there, at least from the security point of view. So typical IPv4 security from 2000, okay, anti-spoofing, you allow everything inside to outside, and you block everything from the outside to the inside if it's not matching an outbound flow, and you deny all the rest. Then you can open some port forwarding, right, or basically opening a hole to allow BitTorrent or whatever. And now the issue, if you think about it, the security policy in any CPE device is often collocated with the NAT function, right? And it is done by the same piece of software. Most of the CPE devices are based on Linux. And IP tables do that's for, at the same time, NAT and security. It's really the case where it's collocated. It doesn't mean that NAT brings security, okay? So IPv6 changed a few things. I mean, it's vastly the same thing, but a few things change. Something I really like is the link local addresses, because they are local, right? Nobody can use those addresses to attack you. For instance, what I say to some service provider, hey, why don't you use between your routers link local only, right? OSPF, ISI, of course, IS, any routing protocols run perfectly fine on link local. But then you cannot be attacked on those links, which is kind of cool. On the other hand, home devices now are globally reachable. Okay, so it means that all your girlfriends can print on his printer with no problem, which is kind of cool from the user perspective. But of course, it means also that I can print on all his printers and print, you know, some F word or whatever words you want. And another thing, this one is maybe a little bit convoluted, but just to tell you, a few things are changing there. So we have there something like a broadband network, and on the left-hand side, this is my CPE and my PC. On the right-hand side, this is Uli's network with his printer, and somewhere we are sharing the same provider, which covers Belgium and Norway, will be kind of challenging, but anyway. So, and we are basically in the same, from the service provider perspective, the CPE are in the same layer 2 domain, okay, the same VLAN, for instance. So in IPv4, you get this kind of link, the green link. In IPv4, all the traffic that the service provider sees is the one address of the CPE, of my CPE, talking to Ole's CPE, right? Because the CPE are doing that. So now, if we are in the same layer 2 domain, we need to apply tricks within the service provider network to force the traffic to go to the BNG or whatever, owned and managed by the provider, in order to do some billing, to do some inspection, to do whatever he wants. Okay, some service provider want to see your traffic. They don't want to get direct connection. So they need to use layer 2 tricks for doing this. In V6, my PC talks directly to the printers of Ole's home network, right? So as we are coming now from one prefix in my network to Ole's network with different prefix, it must be routed. So naturally, it will always go, if you don't get any kind of routing information exchange between the CPE, always go through the BNG, because they got only a default route. So there we are kind of solving the problem. okay, because there is no more need for two CPE to talk directly using the one address, okay? Because my CPE has not changed to talk about V6 with only CPE, only the PC attached to it. Anyway, small difference here. So when talking about the IETF and some vendors as well, what is the simplest IPv6 security policy to be applied in a CPE? And it's basically a copy and paste. And again, I kind of like it because it's congruent. And the user, my mother, my brother doesn't have a clue about V4 and V6. And they need to get a congruent security policy, okay? Else we are kind of opening the door. So it's basically the same thing as before, right? Anti-spoofing, outbound permitted, inbound only if it's matching the flow. Benefits, we know it. Bad thing, it breaks end to end. It means that now, even if I could reach Ole's printer, put on a routing perspective, I cannot from the security perspective. All my packets will be dropped by Ole CPE. Okay, so then we are back to square one. So, back in time. In 2000, we defined the standards for the CPE. CPE were very weak and limited. The OS themselves, we were running Windows 98, right? Or Windows 2000, or whatever Mac or whatever you wanted. Very weak and vulnerable OS. They were attacked. All the attacks as well were done mainly at layer 3 and layer 4 as well, right? We were not talking about a cross-site scripting at that point of time and this kind of nasty JavaScript or Java applets. Security technique at that point of time, it was firewall and firewall and firewall, nothing else. 10 years later, when we are now designing V6 CPE, host, we talk about Vista, we talk about Linux, macOS, and blah, blah, right? All the others, now they are secure. It's very difficult to attack a Microsoft Vista or Windows 7. Don't tell me wrong, because most probably I do it. Same thing for macOS and Linux and so on. But the level is very, very high. CPE device, I mean, we all know Moore's law. More memory, stronger CPU, faster CPU. Something is different. New security techniques appear. Intrusion prevention systems are used everywhere. In each and every large organization, there is IPS. We also work on reputation database. We give to some remote IPs reputations. So we can see, oh, traffic coming from this one is maybe better than traffic coming from that one. Okay, so techniques are there. We rely as well on automatic software updates about policies coming from the cloud. So we change the landscape, okay, vastly. And when I say, hey, OSA is more secure, it's kind of crossing finger here, because all the new webcams and all the new sensors and your coffee machine on V6 and your fridge over V6, we simply need to hope that the embedded operating system there is strong as well. Okay, question mark, because there we don't really know yet. So proposal, and that's a proposal basically that Mark and myself has been pushed to the IETF, is that let's try to do a less simple V6 security, where we rely on the new techniques like IPS, right, automatic updates and so on. And you got the draft there here. And within this draft, we pushed a couple of policies that says, hey, basically use about IPS updated signatures. So you are always up to date. Basically, all of us are running antivirus somewhere. This antivirus database is updated daily, nightly, or whatever with new signatures. I mean, that's modern techniques, right? It's been there for 5-10 years. CPE could use this. No, the issue now, you need to change the business model, right? The antivirus, you pay a monthly fee or yearly fee. We need now, when you buy a CPE of this kind of security, you will need to buy a yearly subscription contract. Okay, so why not? And then this is basically where you got. At that point of time, you use IPS techniques, for instance, or others, to allow free incoming connection. All the incoming connections are allowed. We restore end-to-end. But then we are not naive. We call it in the draft paranoid openness. Yes, we are open. I accept each and every connection coming, but I declare them suspect and dangerous only on a real proof of suspicion when they are in attack inside. If there are normal connection, they are open, they can go through. Okay, so we only block the real evil stuff. And benefit, we restore the end-to-end. Like Mark said, we change the internet architecture, kind of, because end-to-end connectivity is restored. Okay, and that's basically it. So to summarize, I've been working in IPv6 security for many years now. They are roughly equivalent. Training and, let's say, experience is still challenging for v6. So for a few years, a month, a quarter, it will be less secure. That's the only point. But now, when we deploy IPv6 CPE in 2010, let's figure out that 10 years has passed since the IPv4 NAT security CPE has been there. So we need to change our mind there. Okay? We need as well to educate the customer base that we need to get subscription-based security and not only buying one device and forget about it. Okay? They will have to pay to get maybe those updated policies there. And that's it.
Thanks, Eric.
And thank you for your attention, by the way.
Thank you very much, Eric. All right, Rok, if you can come up.
Rok, Arzensek Iskratel, also from Slovenia. Yes, I know Jan.
Are there other people in Slovenia?
You are 2 million, so we know each other. And we used to work at same ISP at the beginning, so basically, we did what we did in Slovenia. Now I'm more than a year in the vendor side. So basically, what we have right now is that we have some kind of the multi-service environment from the service provider or telco, whatever we will call it. It was some years ago, some holy war. Should we use it VLAN per user or VLAN per service? We ended with both implementations with layer 2 and layer 3 CPEs. Ole already mentioned home network, and I have some things to show what implementation we did for our customers. Then from the regulator side is nowadays pushing multi-service, multi-provider environment. We will see how it will go, but anyway, it will need to be supported on the CP. This is one thing, how it looks. The CP, which is VLAN per user, is the implementation which we have with one customer. You can see all this ILG magic there on the router side. It's even IGMP forking implemented there. On one public PVP interface is everything, also the management. If we look to the home network, yeah, okay, we have some kind of the home network, but we have the problem with the different set-top boxes, how to solve things regarding the VOD. Each vendor works quite different, and for each customer you need to do it the customization. Then this is the implementation. If you have VLAN per service, I draw intentionally there that the interfaces are breached, so it's very clear that the home network is breaked. You have no chance to share your content between STB or your laptop or whatever you will do it. On the left side, okay, it's implementation which we have it on the field. Then here is the question: if you have the multi-service box which has only one IP, how to solve that? And yes, these networks on the right side are private networks and are closed. then the first implementation of the IPv6 which we have will be like that. So we will not change nothing. We will just introduce the IPv6 on the internet side. There I will have some slides, but I will skip it because Ole already mentioned. Okay, this is the question. It will be this the ideal device or whatever it will be. In the RFC or draft of the RFC, which Ole mentioned and it's authoring, it's also stated that you can have multiple LAN interfaces. One of the possibility is could that I have the prime or whatever, or today closed services on the one interface, the internet will stay on the other interface. We will still have the IPv4 and all the ILGs there. What will happen here is that we are basically switching from the VLAN per service to the VLAN per user. What does it mean for the network which the operator has? They will need to change everything, or they will start as was on the first slide and then build, I don't know, new aggregation network and access network, and then they see how they will go further. Then here are some things which Ole already mentioned. But anyway, the question is how we will get the GUI interface on the only IPv6 CPE. So there we don't have this famous IP which is the same on this all CPEs. So we should have something like modem.local or whatever it will be, that the guys which are on the field can access the interface, whatever it will be. Then on the IPOE thing, we have DHCP authentication, whatever will be in the end, because and BFD echo mode basically for the generating the CDRs or keep alive things on the layer 3, or we will have something different. Some things are going on in the Europe open access networks. They are basically layer 2 networks. So how the IPv6 layer 2 home gateway will look like, because what we saw today is that everything will be fully routed model. So we don't have any answer regarding multi-service, multi-provider environment, if it will be pushed through the regulator. And the things which will emerge is quite different. If you have the greenfield, then you can start to build quite different CPE. If you have existing deployment, it depends how you decided, VLAN per user, VLAN per service, and you need to solve these things. But in the end, what I would like to see is that we don't break again the home network, that we fix what we need to fix. And yes, I agree. The CP today is quite different. You have more resources on it. Regarding the firewalling, I don't know. Some customers would like to have it, some not. It's probably will be debate, but this is more or less what I have to say.
Thanks a lot, Rok. Okay, so I'd like to have Bob Bain from Arris come up and talk to us about V6 at Arris.
Hi, I'm Bob Bain, Director of Product Management at Arris. Just how many people have ever heard of Arris in this room? Not that many, maybe a few of you. So unless you're in the cable industry, you probably are thinking, who the heck is Arris? So I'll tell you real quick who Arris is. We are a global company headquartered in northern suburb of Atlanta, and we develop products that enable cable operators to deliver voice, video, and data services to their subscribers. And we're probably best known for our carrier-grade, high-capacity, high-performance CMTS, as well as our DOCSIS 2.0 and DOCSIS 3.0 cable modems and EMTAs. EMTAs, embedded multimedia terminal adapters. That's a fancy name for a voice-enabled cable modem. So, so what are we doing in this area to enable IPv6? You know, as a CPE sitting in the home, we see ourselves as a gateway into the operator's network. So there's three, excuse me. So if you have a voice device, which you'll have three IP addresses. There'll be an IP address for your cable modem. There'll be an IP address for the host computers behind the cable modem. And of course, the voice adapter is essentially another piece of CPE behind the cable modem. So that gets an IP address as well. So what I'm going to do here is just give you a quick view of the type of products that we have and then what we're doing and where we're at on IPv6 implementation. We ship, Arris has shipped about 25 million CPE to date, DOCSIS 2.0 and quickly into DOCSIS 3.0. So there are a lot of products out there that will require some upgrade at some point in time to IPv6. And so real quickly, we have two types of products. The two main products we have are the DOCSIS 2.0 products and then our DOCSIS 3.0 4x4 and 8x4 EMTAs and gateways. Excuse me. So in here we have cable modems, we have multi-line EMTAs, we have telephony gateways. These are gateways with 2-line, 4-line telephony services with high-speed internet and 802.11n wireless gateways. And also we have battery backed up models as well as non-battery backed up models. So where are we going with the IPv6 for DOCSIS 2.0? On the IPv6 cable, is this on? Hello, 1, 2, 3. Okay. Okay. Except I can't see that well. Yeah. All right. So where are we at with the IPv6 CM support today? We actually all our current products, all our current DOCSIS 2.0 products support IPv6 cable modem management today. How do you turn it on? Well, the cable modem uses the TLV 5.1, which is in the MAC domain descriptor message, and that basically tells the cable modem whether it should be doing addressing in IPv6, IPv4 first, IPv6 only, or do the alternate mode where you will try IPv6 first and then IPv4. And of course, in networks where MDD is not activated yet, it'll just go straight to IPv4. So to aid in the actual deployment of this IPv6, okay, we also have an MDD override feature that will allow you to turn off the capability for IPv6 in the various parts of the network as you upgrade it. So, right. So the next piece, that solves 1/3 of the problem. The other 2/3 of the problem is the IPv6 address on the CPE and on the MTA. So we are coming out with a new firmware release. All the existing Model 6, the current products that we're selling today, will be upgradable to IPv6 to support CPE behind the cable modem. We will also provide an override mechanism as well, so that the operator can do the upgrades on a staggered basis throughout his network. He doesn't have to try and flash cut everything at the same time. On the IPv6 MTA side, currently we do plan to do this in the packet cable 2.0 based EDVAs. We haven't determined a release date for that yet because we haven't quite got to the point where there are enough networks out there with gateways and call servers that currently support that. But that isn't a plan. All right, so legacy support, this is a very important one. Our earlier models, Model 4s and 5s, there's probably 15, 20 million of these devices out there today. We know that the operators want to be able to upgrade those to IPv6 at some point. The challenge is these were earlier devices and there may be issues with the amount of memory available to do the upgrades. So our challenge here is to figure out a technically feasible way to recover memory from the current devices and look for ways to be able to upgrade it and help our operators not have to go out and do truck rolls and recover 20 million devices from the field to upgrade to IPv6. This is just a quick matrix. We don't need to go through that, but if you're interested, you can see what products we have and what the status is on our IPv6 support. DOCSIS 3.0 is fairly simple. All our DOCSIS 3.0 products meet the IPv6 requirements in the spec. We do plan to introduce e-router capability fourth quarter of this year, and we are looking at putting in DS Lite support as well to aid in the migration strategies. And again, the IPv6 MTA support will be added later on when packet cable EDVA IPv6 networks are available. And IPv6 firmware matrix. That's it. Thanks.
Thanks, Bob. Thanks a lot, Bob. So I'd like to have Eric Vyncke come back up from Cisco to talk a little bit about some of the work he's done on the gateway side of things. Thanks, Eric.
Okay, still Eric, still working for Cisco. Now this time about IPv6 on the CPE. So Cisco in itself, as you know, is shipping high-end kind of CPE where you get everything with iOS, not the iPhone OS, right? But the good old iOS from Cisco, changing it away with everything. A little bit too expensive for my father or my brother, right? Only at home I can use it for me. But within Cisco, we have what we call the consumer BU, something that you know about flip camera or Linksys that you buy at Fry's or at Best Buy or whatever. So what are we doing there? That's basically the talk here. So, and it's not only about, running OpenWRT on the Linksys device. No, more seriously. Mark will tell you tomorrow morning, starting at 8 or 9, I don't remember, instant time. 7? You're kidding?
No, 6.
Okay, you're kidding. Okay, oof. I'm relieved. Anyway, so we'll tell you about the commitment of Cisco for V6. I'm not talking here about the Linksys because Linksys product family, because it's included, of course, in the Cisco commitment. And it's not limited, of course, to any CPU or RG that we talk about. Okay, whenever you want. So we have a proof of concept for a couple of months or even a couple of quarters running on existing hardware with a brand new image. And it's been tested on every continent except Antarctica, I must say. It has been tested over cable modems, over ADSL, using DHCP, using 6RD, of course, right? What do you expect from us? Even in some cases, when you receive a /64 from the provider, we need then to bridge V6 while Narten V4 at the same time. Kind of weird, but that's all we can do, right? Mark, for instance, in France is receiving a /64 from Free only, as far as I know. No.
Well,
Yeah, you get a router announcement with only a
/60, but it's just that the router doesn't know how to give out anything but a /64 on the LAN side.
Yeah, so then you get a /64, right? So doing DNS proxy, doing Slack, DHCP v6 on the server side, on the one side, and on the client side, of course. Usual stuff. Oops. So now, it's obviously a system that's based on the Linux kernel. So there are some challenges there. One is that a lot of applications are only single address family. So we are running 2 DHCP processes, okay? One for V4, one for V6. It means that if you have to replicate this for a lot of applications, you end up with double size of memory, which is not always easy. Then, of course, what is the default setting for the security? So we have some internal disagreement between my friend Ole and Mike and myself on this one. But of course, the end user will have to decide, right? Can override the default settings there, that's pretty sure. Other point, how much on a dual stack CPE are we hiding IPv6 from the user? Okay, my brother, my father, again, have no clue about V6. So when, for instance, I say port mapping for the V4, allow all the web traffic, port 80, to this specific IPv4 address, because it's existing stuff. What does it mean for V6? Mean that every port 80 can go through, or something different? So it's not always easy, right? We would love to get something which is completely hidden for the user. If he doesn't want to know about v6, he doesn't have to. Okay? Which level of auto-configuration as well? Okay, for instance, we boot, we try to do DHCP v6 on the one side, but for how long do we wait until basically maybe falling back to 6RD with static configuration? If we have 6RD configuration through DHCP v4, then we'll do it immediately. But if we don't get it, do we wait before starting 6RD, or do we start 6RD immediately? Okay, the default settings can be a bit challenging there. And then a couple of questions for all of us. Okay, what about DNS? Do we need proxy DNS? But then we are breaking DNSSEC. Okay, I understand it's an IPv6 conference, but IPv6 deployment is basically collocated in time with DNSSEC deployment as well. So the CPE we designed for v6 must be compliant to DNSSEC, meaning DNS proxy cannot be used, right? Then how to replace this famous 192.168.1.1. Okay, you can use Bonjour, but what about my Windows? If you are using service discovery for Windows, what about my Linux? We need to get a system which works for everyone. So not always. There's Bonjour for Windows. For sure, I got Bonjour my Windows at home, but my father's doesn't have Bonjour.
Why do you have to replace?
Sorry?
Why do we have to replace?
For managing the box.
It's still there.
Okay, but I do agree. I do not want to get on my brand new IPv6 box. Please go to 192.168.1.1. But I agree, right? We could do it this way. I mean, it's not a killing stuff, but I mean, it would be nice if we could find a good idea there. What about PPOE? Is everyone, I mean, currently we're having a CPE. If you do PPOE, we do a dual stack PPOE. Now, some service provider in Europe wants to have two PPOE sessions. One to the v4 to the existing BRAS or BNG or whatever, and another one for the pilot phase to a single BRAS or BNG, which is the piloting the v6. So then we got, I think all the questions are for the end, if you don't mind.
I just wanted to comment on Chris's comment. Just put a colon in front of 192, and you get what you want to.
Good one. Anyway, then the other part is when shall we removing the dual stack and get only a v6? We all know that. And then the last point is what already alluded to Ole. In Europe, a lot of service providers are simply renewing the v4 address every day because they want to prevent you to get a server on a free or mostly cheap contract. And when they talk to them, they will do the same thing for v6. They will be renewing the prefix delegation every 24 hours or 36 hours. So we need to remember immediately on the inside. Okay, that's doable, right? I mean, you just send an array with the old prefix and refer lifetime to 0 and done. But it's kind of bad, right? And then what about ULA? I mean, do you really want to get a ULA per device? And then how can we be sure that the random number there, the time and everything, does not provide any collision? I don't know. That's basically it. So CPE are coming, and what Vincent said this morning, yes, no, the last mile CPE with IPv6 are there, right? I mean, for multiple vendors. So.
Thank you, Eric. Okay, so last but not least, we're going to have Hans from Dlink come up, and then after Hans, we're going to take about 10 or 15 minutes of questions. I think if we have a good discussion, we have a little flexibility. So I will. Hand it over to you. Thanks, Hans. All right.
Hello, everyone. Okay, this Hans from Dlink Systems. Thanks, Eric. I think Eric covered almost all my slides, so I just go through my slides quickly, and I see everybody are so tired here. Okay, this news I captured from Gartner last October 2009. I think it says that don't sweat, move to IPv6. What's that? I think we have been talking about IPv6 for somehow more than 10 years. And since now, we still see that a lot of spec and a lot of standard are not finalized yet. And from manufacturer, home networking manufacturer point of view, we still get a lot of service code every day. Either probably because our product itself, but also because people still have less knowledge in how to set up and how to configure their product. So now we're talking about switch to IPv6. And as we can see that address is running out, I think this also been covered. What I want like to cover here is that more and more digital home applications. I think here we have people from all industries, but not TVs. Since this year, we saw that a lot of TV are going to have internet connectivity. Even Vizio is doing their own routers as our competitor right now. So IP address of either IPv4 address or IPv6 address, the IP connectivity or the internet connectivity is certainly going to increase due to these home networking applications. This slide, I would just want to highlight that 3G PPE and WiMAX already support IPv6 as mentioned in earlier this morning. So I would like to focus on to our commitment and our strategy to IPv6 support. We have all of our new routers as well as 11N, L211N routers support IPv6 for all of our home gateways today. And we are very proud that we have already have 21 of our devices certified by the IPv6 ready program. And I think Dlink is only the only vendor who just, crazy enough to promote the IPv6 direct from the Gitbox and shipping distribute this IPv6 home gateways direct to the retailers to home users. And I think this covers some problems we hear today in the morning. Yeah, the problems that lacks of the home gateway device. So the key we believe to drive the IPv6 is to have your router home gateway to start support IPv6 first. Then we talk about IPCAM, NAS, and the other home networking devices. So this is our roadmap. Now all of our home gateway device start support IPv6, and we will gradually extend that to the other home networking devices like NAS and IPCAMs. So also I would like to here talk about that. What's our problems here? I think Eric covered most of them for me, but to me, we have been talking about IPv6 for 10 years. So what's the next? And there's so many transition protocols. So it's really hard for us manufacturers to design either the UI or which protocol we are going to support, which transition mechanism we are going to support. All right, here is what you can see, what you can get from the retail today in our CPE routers and with this IPv6 feature support. We have IPv6 in IPv4 tunneling, which the original tunneling broker, 624, 6RD, and torrent pass-through. For native dual stack, we support static IPv6, DHCPv6, PD for the LAN and auto configuration, and of course PPPoE. Yeah, we have today. You can just get it from retail. Yes, and as long as you see the IPv6 logo on the Gitbox, it's ready today. Yeah. All right. And we suppose LLMNR, as we say, it's ridiculous to have IPv6 box, and you have to go through the management interface through 192, 168.01 or 11, yeah. So we suppose LLMNR. However, we also urge that the platform like Windows, Mac, I know Bonjour already support LMR and sort of Windows 7, but there are a lot of platforms doesn't support it yet. So it would be great that people can use something like Dlink router, Dlink AP to access your management page, no matter what your IP is. And in our box, they support IPv4 and IPv6 and NetBIOS, of course. And something I also would like to address is that the RA, the DNS option for RA. I know that Windows 7 is not supported, and I confirmed from the Windows 17, and I don't know if the other platform have a plan to support it. Yeah. And here you go. List all our models that support IPv6 and already certified up by IPv6 Ready program. Yep. So that's my slide. Thank you.
Thanks, Hans. So what I'd like to do is open it up for questions for folks. We have a few minutes for questions, and I was kind of expecting there to be plenty of them. Stan?
Hi, Stan Barber. I've spoken since a long time about IPv6. One of the things I've looked into recently is home networking, and it's great that you guys are working on this. What is the relationship between what you're doing and the folks at the, what's it called, the Digital Life Networking Alliance or whatever they're called? The guys who actually build the little boxes that you attach to your home networks that aren't routers, doing to be sure that everything plays together in IPv6.
So are you talking about like DLNA? Or?
Yeah, Digital Life Networking Alliance. Is that the name of those guys?
I don't know. Any guys have any comments about that?
I mean, it doesn't make a lot of sense to have IPv6 in your local home network and you can't plug anything but PCs into it. At least I like to have my, Blu-ray player do IPv6 and these other really cool things.
So Stan, I can tell you, I don't know if these guys are able to comment on that, but I could tell you two things about my experience with that. I exchanged some emails with those folks, and they basically said that there's nothing to do from a V6 point of view. I of course didn't believe it, but I didn't have anything more to anything further to go back and forth with them on. I know that on other fronts there are some efforts going on to make things like televisions V6 capable, but today I don't know if there's been any sightings of them in the wild.
Matthew from Internode in Australia. We're a DSL provider, and we've tried to provide IPv6 native to customers over PPPoE. And I guess one of my comments about CPE is our general frustration has been the complete lack of them for actual ADSL CPE. I understand Dlink have some routers, and I understand some people have some code for separate home router sort of gateways. But one comment about the Broadband Forum stuff is, to a certain extent, it's all very nice to think about, do we have the firewalls turned on, and do we have all this complex networking in the home? Can we just come up with a standard for actually doing it and start doing it rather than continuing to worry about how we're going to do it in the future? Because I want to get on with it. I really do. And it's actually really hard to convince a lot of our DSL CPE vendors to actually get a move on, because a lot of them are going, well, I don't know what to do yet. There's all this stuff that hasn't been decided yet. And, bless me, I've got two of them who've come out with code for us. Not Linksys, I'll point out, for DSL modems, and not Dlink for DSL modems. And it's really frustrating. Can we maybe just have a phase 0 implementation of, hey, look, you can do this and we can get on with it, please?
Well, so I didn't say very much about that because it's simple and it's done, and it's more interesting to talk about new stuff. But so we've forgotten how to run multi-protocol networks, right? If we knew how to do this in 2000, you had a PPP-based DSL network. It was multi-protocol support, right? You could just turn on V6 and it would work. Then these SLAM vendors started to do, fancy things in the network and look into PPP sessions in the middle, and God knows what, right? So these SLAMs were suddenly V4 specific, even though they were layer 2 devices. And now with IPOE, if you're running that, it's lots of, well, good. But if you were, then it would be lots of v4 smarts in access nodes, which would have to be updated. But this is all, I didn't talk about that because that's all in the access network. But for the, for the CPE itself, the broadband forum is done. There might be some issues with in the access network, especially around IPOE, how you need to replicate all the v6 functionality, how you have to get v6 support in access nodes and stuff, and that's why Mark came up with or worked so hard to push 6RD, because you just tunnel across the whole thing and wait for that to sort itself out. But broadband forum on CPEs, we are done, and it's it is the basic stuff. Getting phase 0, get v6, basic v6 connectivity, and yeah, just ignore all these new things because that's job security.
Because you're scaring the CPE vendors. I mean, really,
I know.
I've got a network, and if they've got a Cisco 877 or something like that, they can plug in and it works. But actually getting CPE out there to get people using it, I mean, 0.1% of my customers have signed up for the trial. 0.1%, because they don't have CPE. So anyway,
but I mean,
CPE vendors, get on with it.
If you read the IETF draft, it's, I don't know, 11 pages or something, and it's very, very simple and basic. So, but you're right.
And that's not an uncommon sentiment that you're offering, right? And that's part of the reason why Uli and a lot of other people had stepped up and drove the initial version of the draft through. I mean, it's probably been less than a year at this point, right? And your frustration is not rare, right? So and I think a lot of the work that's happened there has kind of helped out on that front. Ron? Yeah,
wanted to respond to Eric's comments about equivalence of IPv6 and IPv4 from a security perspective. I think you pointed out that the difference might be along the lines of user experience, operation experience, and so forth. My additional concern has been implementation maturity. Since we have 25 years of experience living on IP and IPv4 and found all the bugs in a lot of the implementations, where we've had almost zero experience relatively for v6 implementations in all products. My fear is that there's a lot of latent implementation bugs, and we're gonna be. I bet you we will be seeing lots of denial of service exploits out there until we discover this and get more of the v6 implementations fielded. How do you respond to that? You agree?
Okay, I agree with you. Maybe we can have learned when developing the software. We maybe have learned from experience. Mm-hmm. For instance, control plane policing is done by day 0 for v6. It was not the case for v4, so we learn by experience. But for sure, I am coding. A lot of us are coding, and we are making mistakes, right? We are human beings, so yeah. Okay, agreed.
West George. Question / comment from my esteemed CPE vendors. It's all well and good that you guys are doing work to make new boxes support IPv6, and I'm very happy that I could walk down to my local Best Fries and buy a new box. But what about the existing ones? Where's the firmware updates to support IPv6 on those?
Okay, I will reply in the end.
Rok?
Yes, if we are talking about ADSL 2+ boxes, it will be quite difficult because you don't have the resources. Basically, the main CPU and things which are there, if you are in fully routed model, they supported just the bandwidths which were around, let's say, 20 megabits if the reasonable big packages were there. And you have limited space of flash and RAM on the box. So basically, we know if we go in dual stack, then we need to have more resources. One possibility is if you're using the PPP, that you use PPP pass-through and you plug bugs behind it. So this is one thing. Or if you have the model which was more costly, but anyway, when the customers are buying the CPEs, the most important thing is the price, because the quantities are big. So basically, if you would like to have a lower price, then what you do, you cut off the flash, the RAM, and you change probably the power supply, and then you end it with what you have it. So basically, if you are willing, we have only one case that the customer was willing to have more resources. In the next year, we will come also with the software for this box, but for the older boxes, sorry, because the main issue was price.
Yeah, I should probably have clarified. What I mean is more the standalone boxes that you plug into the end of some other terminating device. Because you look at it from the perspective of there are plenty of things now where I can walk up and ask for a box from Comcast, and they're going to provide me a box that does wireless and has a couple of Ethernet ports on the back of it, and it kind of stops being my problem. But in the early days where it was a cable modem and you plugged something into the back of it, a separate box that did your wireless and your Ethernet and your NAT and all that kind of stuff, I'm more talking about the boxes that I would walk into the store and purchase, not what my vendor would give me.
It's different. On the VDSL2, right now you will not have the boxes outside because you have compatibility issues with the chipset vendors. So basically, you will not get it. Out of box things is, if you would like to get from the shop, it's a problem that you have always the specific things for the telcos or service providers. So basically, we don't have the case that we need at least 2 or 3 weeks to make some tweaking modifications with the same features, but they are in quite different ways to use, and it's very difficult that you will get, depending of VLAN per user, VLAN per service, and then some special implementation there that you will just get the box out of the store and that will just work. So basically, all the boxes has some kind of the customization is done on it. So basically, either you will just choose the general box which doesn't support these all things, and I agree with Ole that you have then the DSLAMs which are doing the snooping functions, and it's not so easy if you have multi-service environment.
And if I can make one comment, Wes, I know that there are some cases where you can upgrade existing boxes. I mean, we're aware of some as well, and it actually goes back to something. I want to tear another page out of Vince's keynote. I mean, it's an issue, right? I mean, I forget what he called it, but something for clunkers, right? I mean, it's we all know about that problem, right?
Well, and I think the issue I'm having with this is that people are hiding behind the hardware constraints of the device. But somehow OpenWRT seems to be able to make it work for a much larger variety of devices than actually exists some sort of a firmware upgrade that enables IPv6. So that's more the reason for my question is, either you need to make the decision and say, okay, we're kind of writing these off. If you want to do this, go use WRT. That's our officially recommended solution, or backport it.
How much are you willing to pay?
That's the point. It's supposed to be free. It's already something I bought.
Okay, I don't know who was first.
I was just going to say, I'm going to say we should cap the line. Just going to move on to lightning talks. So, I mean,
try to be brief.
Yeah, but,
I'm not good at
here
it.
It is.
Just a comment with respect to V6 is new code, therefore there's going to be new bugs, therefore all this kind of stuff. Just a perspective moment, I think you'll agree with me, but I wanted to say it, is that all the alternatives that we see because of that 6% is left problem and the V4 exhaustion techniques, in particular A+P kinds of things that are new code on a CPE working with new code on a BNG in ways that they have never worked before together, or new carrier grade NAT functionality. All that's new code too, and new security attack vectors. We're running into new code no matter what. So that you can't just take the V6 off the table and not go down the security problems path. We're going there anyway.
Hey, wait a minute. We're running out of IP addresses? Wait a minute. Nobody told me that, dude. I didn't get the memo. What happened? Shin?
Yeah, this is Shimeka from TATA Communications, and this is very interesting presentation. Thank you very much, first of all. But also lots of people already pointed out what I'd like to talk. But one thing, if you cannot fixate the specification, actually we cannot do that right now. For example, we operators doesn't fixate our specification itself. Maybe the IPv4 and V6 PPPO is the same, or maybe the separate, and still, even for us, didn't fix it yet. So, as he said that, please have a room for the flash and those RAM so that we can upgrade later. Basically. And if you can do that, then please open up the source code. Even if the point is sometimes you guys created and sold to the people, then untouched, never. At least if you have a code on the source forge or somewhere, maybe some guys in the world can upgrade that. So please consider that support or maybe the free source code, please.
Yeah, I think that's probably a really good point. And that was the follow-up I was going to make to Lorenzo's comment about how much do you want to pay for this. I think
Then in that case, maybe we operators can support for that upgrade. In that case, we can pay for that for our customer, right? That makes sense.
The reality is that for everybody in this room, IPv6 represents kind of an unfunded mandate. There is some portion of it that you're going to have to do, and you're going to have to spend money on it, and you're not necessarily going to see a return on it other than you get to stay in business. So it's a shady business case. I'm asking my vendors to share the pain.
Yeah, the truth, first people who like to motivate these kind of things is the ISP will enforce to be the shortage of the V4 address. So the new customer come here, then please give me the fiber to the home. But there is no IP address. So we have to give the IPv6. So we have a reason to pay. Sometimes that happens. Anyway.
Just to comment on this upgrade and so on. So there are two kinds of CPE, right? The one you buy at Best Buy and so on, with a lifetime of 1 year or 2 years, and then it's over, end of sales. And the one you buy, from your vendors as a service provider, this one is maybe upgradable. Now to your questions about, where is he? Yeah, will the subscriber pay for a new CPE? I know people who buy a new CPE to get a faster wireless. So why not buying for something which is end-to-end communication, where your BitTorrent, where your Skype or next application will work better? I know people that will buy it. Not because it's V6, right? But because it opens back the internet.
But and to Eric's point, that's why it's key to make sure that when those devices are built, that they support V6, or at least they have enough room to be upgraded to support V6.
I just want to make a comment about the upgradability. Back to Rok's point, the earlier legacy devices, there always is that hardware limitation because you're talking about high volume products, there's always a cost optimization concern. The operators don't want to pay; they want to pay as little as possible for these products. So you got to cost optimize it, and when you do that, you are going to reduce the amount of RAM and the amount of flash. What we're looking at. From the Arris perspective, we know that our operators, don't want to go out and spend $100 million to go out there and replace all their existing legacy CPE. So we are going back and looking at our legacy products and looking at ways to remove other functionality that might be lower priority. So we're asking our operators, okay, you want us to go and take your 5-year-old device and squeeze out 50K of memory so I can fit IPv6 CPE support in it. What are you willing to give up? And you know what? What are you willing to pay? This is a 5-year-old legacy product you've paid for. You've used up the value. The product's been discontinued. It's no longer supported. As a vendor, if I have to go and upgrade existing product, I have to support it for another 3, 4, 5 years. I've got to get paid for it. I got to pay the engineers. I got to pay, my tech support people. So, there is going to be some cost, but it's a business case, right? As an operator, would you rather spend $1 or $2 per device that you have in the network now and upgrade it, or would you rather go and spend $120 to go and retrieve your how many boxes? 5 million?
I don't know.
Do the math, right? So the business case is very strong.
Yep. All right, so last but not least, last question.
Yeah, Walter Klutenstoft at home. We're also a CPE stack vendor. I have a list of things. DLNA, indeed, yes, there is IPv6 support in it. In that, it's quite straightforward. What IPv6 opens up is the possibility of actually communicating between homes. Now it's strictly private range IPv4. You could have the opportunity to stream from home, video from home to home, for instance. That's something I don't think is solved. The access networks are a big issue. Where's the Alcatels? Where are the DSLAM vendors? Are they on this conference? I didn't see a track for that, but that is a major issue. The legacy out there, which comes to the point of the CPE vendors. It's not that easy to say that just be over and done with it, because you have all these different access networks which were designed in a completely different way, which have different hardware, and there is no one single solution. And that's actually a pity. There should have been more standardization along the way. There should have been a restriction along the way, but there hasn't been. One of these things is, for instance, PVPoE. Can we kill it, please, already? It's really stupid. I mean, it knocks 4 bytes of your MTU size. It's grossly inefficient. We see our customers moving to pure IPoE, which makes it much easier to do dual stack and that sort of thing as well. And then what do we have? Oh yeah, the security policy. So as we see more networks going to ISPs putting managed boxes into people's homes, you said that they should have a service contract for the security updates. Well, those managed devices, that could be a part of the service that those operators offer, of course. That is much harder to sell indeed with the likes of Dlink. Sorry, I buy your hardware from my home, but I sell hardware that is I sell software for hardware that is managed. So it's going to get harder and harder to get an unmanaged box as your gateway, because all these different operators are trying to squeeze more value out of the solution, and in a controlled gateway, they can do that.
Okay. So 2 more questions.
To your point, Alcatel was invited. They didn't reply. In case somebody else is curious, Akamai was invited. They didn't reply. Microsoft and Apple were invited. They may be here, they may not. So make of that what you will.
To Apple's defense, it was their WWDC this week.
I think we might expect something from someone from Apple, and Dave. I know that Dave Taylor is at the IB retreat. We would have loved to have him, but he's has other commitments.
Mark.
On the cost issue, I just want to point out one thing. So Lars Eggert at Nokia just did a study of a bunch of NAT devices out there. Okay, collected them together and ran tests, and he found that the number of flows because of the NATs and such supported on stuff out there is somewhere between 16 and 1,000, okay? And then it maxes out, right? Because of these limited resources you talk about. Understand that with IPv6, if we have that option that says, transparent mode, turn off my firewall because I have firewalls on my hosts anyway, you don't have to track any flows at all. Tens of thousands, hundreds of thousands of TCP connections, and the CPE does nothing, no RAM.
Yes.
Yeah, but your BitTorrent will still run on IPv4. So I will need to do dual stack. So I will need to support all your things on the IPv4 and additional IPv6.
Maybe it's a lightning talk.
But the IPv6 is just a simple forward. You don't have to track the state of it.
Yeah, okay, but I will still need to support everything about IPv4.
Okay, well, maybe I'll have but the user ends up with tens of hundreds of thousands of flows instead of just, 800.
Yeah, I understand, but I have the same resources for IPv4 and IPv6. So I will still need to support everything on IPv4 at the first phase and additional...
No,
yeah,
all the traffic
guys, we're done.
Less resources of
rat hole. Thank you all.
Thanks everybody.
Thank you, John.
Thank you, Google. Thank you, Eric Lorenzo.
Thank you for the panel. All right, we're going to just try to run through this lightning talk session. This is like kind of all the space that we have since the rest of the agenda is quite packed, and this is going to be really, really fast. I'm thinking probably no questions. 5 minutes. I'll give you a countdown.
Stopwatches for.
Oh yes, we've got like 7 of these to try to get through in about an hour. So bear with, and I have everything here, so it should be easy to go.
Awesome.
Take it away.
Grab that one because I have to lean down to get to that one. All right, thank you. All right, so we are going to talk about geolocation IPv6 very, very quickly. I'm Nate Grassman. The rest of the team members are up there, and we represent Quova. If you don't know who Quova is, we've been doing geolocation for the past 10 years, so we know a couple things. We're just across the 101 over in downtown Mountain View. And what we have now is an alpha product. I'm going to say that again, it's an alpha product, so we're looking for people to partner with us to understand our data better and how it fits into the V6 world. I think I'm preaching to the choir here because my coworker saw that we mentioned geolocation 3 times during today. So these are the general areas you use it. But the important thing is that it's pretty much impossible in the V4 world today to search, to buy something, to get online banking, anything. And naturally, as Quova, we see that you're going to need this in the V6 world very soon. So to that effect, there are some difficulties, though. As we all know, it's difficult to make V6 work, and it's going to be difficult in some respects to make V6 work from a geolocation perspective. Here's a couple areas to consider. We already said that carrier grade NAT is bad. It's bad for us too, so we'd like V6 to go ahead and succeed. It's a really big space, which is a good thing for addresses, but not so good for us because it's a little tougher to target trace routes, host names. How do you scan an area as enormous as, or as large as the V6 world is? And tunneling transitions 6 to 4. I mean, there's a lot of raised voices about what's good and what's bad in that area, but it makes it a little difficult for us as well from a geolocation perspective. So let's start talking about the data. I want to emphasize again real quick that when we look at the data, this is the V6 world as a whole. We're not talking about specific who's really using it. I'm just looking at the space that's out there. And I like this slide because it's very dramatic. It basically says there is the registries and then there's everybody else. And if you break that down, you see, I can't see very well from here, but you've got Afrinic, RIPE, APNIC, and the DoD that basically dominate the current allocated space that's out there. This doesn't really include what is routable. I want to point that out real quick. If you include routability, then things are going to change. So from here on out, let's go ahead and ignore those guys because they really mess up my numbers. I think this is a lot more interesting, though. I do know that a few of you are up here are in the crowd, so please don't yell at me real quick if you think you should be higher up there or you aren't mentioned. I just looked at these from the registered organizations, and so they could work out differently if you add certain ones together that were different. But here's the top 10 that make up 82% of the IP addresses, the V6 addresses out there. If we go and we skip over, or sort of, can everybody see this real quick? All right, I'm going to go and switch over to the next one. Next one is at the top 10 countries. So these 10 countries have 92%, it would appear, of the V6 space out there. If I switch back and forth between the carriers and the countries, there's a pretty nice little combination because Deutsche Telekom owns a ton, France Telecom owns a ton, and it works out equally. And us, in the United States, we just broke into the top 10 in the top 10 spots, so go us. Let's talk about the alpha very quickly. As I just said, it's an alpha program. What we're putting out there mostly is for you as the customers to get a chance to build your systems around it, get it integrated, start playing with it, and see to how it scales and all that good parts like that. And then we would love to have the feedback as well because it helps us to understand better how to tailor our own systems to complete the geolocation itself. Because you are the people out in the field in the trenches that are seeing who's using V6. We're in the rear with the gear, and we love that feedback. And if you're familiar with our GeoDirectory services or as a data file, either way, we have a way to get it into your current environment so you can start playing with it. And stop at 4 minutes. So. Oh, and if anybody wants to contact us, I'm Nate Grassman down at the bottom. Perry is the one that really runs the alpha program. If anybody's interested, feel free to contact either of us. If you think I'm friendly, contact me. Either way.
Thank you very much. Thank you. Perfect. Let's see. I think Jason, are you next? I think you are. Jason has something that I think has great promise for assisting users. Debugging things. Would you rather have this?
That's good.
All right.
So this will be very, very brief. Test-IPv6.com. Speaking only for myself. We've mentioned that the content providers are doing testing to see how many of their users are going to be broken That's wonderful for the content providers, gives them a lot of insight, does absolutely nothing for the user. This will. Very simple. Does the same kind of beacon testing. It will try a series of URLs, see how long they take, see if they time out or not, try to declare, will this person be harmed when a content provider starts to go to IPv6? More importantly, will they be broken when the provider is only IPv6 in a more distant future world? This is an example today on the Google v6 Wi-Fi. Things pretty much work, other than the resolver does not reach a v6 only resolver on the outside. Not so bad. This is on my cell phone. v4 only. Things will work. When somebody goes to v6, they won't be harmed by it. They're just not in an ideal situation. This, unfortunately, is about 20 minutes ago on the Google normal network. Somebody is advertising a bad route. Everything's broken.
Is it still that way?
Hmm?
Is it still that way? Are there still rogue RAs?
Not sure. This looks like it's a 6-4 being advertised. I've got a MAC address.
The guilty.
If this is you, please stop. Feedback welcome. If it detects any particular cases that it doesn't understand, it will have a form at the bottom. Please fill it out. Give me contact info so I can help better understand it. Thank you.
Oh, you only used 2 minutes, so you got a second. Is there...
Show the demo.
Show the demo? What do you think this would take to handle tens of thousands of users maybe checking? Maybe not simultaneously, but...
I probably need a little bit more connectivity from my provider and a little bit more cache.
Okay.
So please don't /dot me.
So, but it's okay to put it on
Share
Twitter?
with your friends. Yeah.
Like Twitter?
Eric's got lots of friends.
Okay. Looks good from here.
That was quite fast. Yeah.
No, this actually has nothing to do with the client having v6 DNS resolution. This is using the normal resolver. It doesn't know which way it is. The resolver that is being used was told to look up a name that is only DNS lookupable over v6. So from here to resolver to a v6 authoritative, that broke. Eric?
Yeah, it says that the DNS resolver that he's talking to does not have the ability to make a query of an authoritative server that is IPv6 only, and that is in fact the case at the moment.
So in this particular case,
so it works.
When there is DNS or v6 glue records, some of your lookups may be delayed. Thanks.
Excellent. Thank you. Superb. We're moving right along here. Thomas. He only took like 3 minutes, so you grab a few minutes more if you wish.
Well, I have 3 slides and
3 slides. Speak slowly.
All right, thanks. Well, I can easily talk longer. This is a big program. But I thought I'd just really give a brief overview of the USGV6 program, mostly because it's been around actually for a long time. It's going into effect pretty soon, and I'm surprised at how many people I run into that actually don't know very much about it or weren't really aware of it when they probably should have been. All right, so this is really about U.S. government requirements for IPv6, and it starts off with, in 2010, starting in July, IPv6 and IPsec are going to be procurement requirements. And if you look at the history of the U.S. government with IPv6, they have a very long history of making requirements or saying we want IPv6 deployed. And I think earlier today, one of the talks started off at the DoD in 2003. I think that's the earliest one. Okay. Over time, the requirements have slowly been ramping up where they get more specific about what it means to do IPv6. And the one that's going into effect in July is now a very detailed profile that lists individual RFCs you have to do and also includes a testing regimen where you have to take your products to a testing organization to verify that it actually complies with all the relevant pieces of the IPv6 standards. This was made binding by a federal acquisition regulation, that's a so-called FAR. This is the way the U.S. government turns policy into procurement law. And what it means is that as they start doing procurements and to a vendor, the vendor will be asked, show us what you're doing with IPv6 and that it matches our requirements or that it supports IPv6 in the following ways. That's the way these sort of things roll out. The scope of USGV6 is it covers all devices or products that embed an IP stack. So that means anything, the obvious things like an operating system, any kind of hardware software package that's bundled together that has a stack in it. If you're running sort of a network appliance or a router that has some sort of v6 stack functionality in, you're going to be in scope for this. The USGV6 requirement is really two parts. There's what we think of as IPv6. That's all pretty reasonable. And in fact, when I talk to people that are doing this and vendors, the v6 requirements aren't that hard, but they've also thrown in security and IPsec, and in particular, IKE version 2. And from an industry perspective, IKE version 2 is sort of a new mandate. It's not really widely deployed in industry at all. In fact, it's not really deployed at all in industry today. So they're pushing the envelope on that. And of course, the fear from vendors that sell to the federal government, there's an assumption that this sort of requirement is going to become a checklist where you have to have it or else you're going to be turned away at the door or you're going to have to fight really hard to get people to look at your product because it doesn't meet some set of generic requirements. Okay, so how is this done? NIST developed this over a period of 3 years. They have a number of documents. There's a profile document that describes 3 network classes, device classes: hosts, routers, and what they call a network protection device. There are specific requirements for what each class needs to implement in terms of functionality, because obviously the host functionality will be different than the router functionality. They've created a testing program to back it up that involves third-party outside labs that go and test the individual RFCs that you're supposed to have implemented to. Currently, UNH IOL, which does IPv6 ready logo testing, and ICSA are doing that. And when you're done with that, the product issues what they call an SDoc, or Supplier's Declaration of Compliance, that essentially says, here's what we have implemented, and here is the testing lab where we tested it, so you can go look at the results and verify for yourself that we've really done this. And sort of at a high level, there's been a pretty good collaboration, in my view, between NIST and industry, in the sense that NIST, they put out some draft profiles, they got a bunch of industry feedback, they revised them and modified them, and what they've actually produced at this point is not as nearly as onerous as it could have been if you'd imagined. Well, not even just imagine. If you look at some other programs that have been put into place in the past, they've leveraged the IPv6 ready logo work tremendously. There's an MOU signed between the two organizations where they're essentially pledged to work together, develop this, the same test set, so that as you're doing one, you automatically get tested for the other. There'll be open source test toolkits available, so you can do that in your own lab. So at least as you're doing the product development, you'll be able to test this stuff and be pretty certain that when you go to the external lab, you know what you're going to expect and you already know whether you're going to go through or not. Okay. So in isolation, the NIST profile is policy free. So this is one thing to keep in mind. NIST does technology. They develop what the profile is. They talk about the technology. In terms of policy, who is required to do this, what it means if your product doesn't comply, that's policy that's done by OMB. Okay, completely different part of the U.S. government. So practical impact of USGV6 for all of us. If you talk to NIST, what their intention was in creating this program was essentially to provide additional market pressure This includes both IP. Talk to them specifically. The IKE version 2 IPsec security requirement is designed to bring sort of two things in with IPv6, not just a larger addressing space, but actually sort of increase the overall baseline of security that's available or potentially available. And what USGV6 does is it creates a way for the federal agencies to express what their requirements are in a sort of a vocabulary that everyone understands using the profile. It says, like, if you want to be USGV6 capable, that means you've implemented the following RFCs, and everybody agrees on what that is. In fact, if you look back on the sort of the previous requirements, the government might have said you need to do IPv6. Well, people could turn around and say, like, we've done IPv6, and people say, well, what does that really mean? Like, well, we did everything except for this particular standard, and it turns out that's a critical one to make your product actually work in the field. So we know how that game works. So the December FAR requires agencies to essentially issue requirements or state what their requirements are starting in July of 2010. And what the actual agency will require or request, we don't know yet because they haven't really done this yet. And they may request less than the NIST baseline, or they may actually request more than the NIST baseline. The assumption is that most are just going to say, this looks good to me, we're going to do that. Okay. DoD has their own profile work that they've been doing. They've been sort of working in tangent with the NIST work. So they've already expressed essentially what their requirements are. They're largely lined up. They have some different timelines. And as an overall result, what's happened now is that the vendors that sell in the federal government are essentially adding more IPv6 support and more IPsec and IPv version 2 support to their products than they would have otherwise in the absence of this program. Okay. In terms of what's going to actually happen when this goes into effect, it kind of really remains to be seen what the individual agencies are going to do. At one level, they are required to do this. They are required to state what their IPv6 requirements are. In reality, there's always going to be a little bit of wiggle room. There's an avenue for exceptions. If you look at the writing, it requires the agency CIO to make an exception. How hard is that to do? It depends on the agency. It depends on the vendor. It depends on how well they like your product and all kinds of factors. And this creates sort of a bit of uncertainty for product vendors that if they don't have this functionality, maybe they better get it, because if they don't, they're going to be disadvantaged, especially if their competitor over here is doing it, or we're not sure if they're doing it, or how up to speed they are, and so on. And so this really creates sort of a just generalized pressure to put more IPv6 into products. And I think that's what's happening. I'm pretty familiar with what's going on in the program. I'd be happy to talk to people offline more about it. But if you go talk to UNH, they've got they're getting products tested now. We have some in the pipeline. I know Cisco and Juniper and others do as well. All right, thanks. Any questions? Pardon? There's two answers I can give. I can say they're very different because the DoD JIDIC work is like they've done their own thing, completely separate, and from NIST. That said, if you look at the actual technical requirements, they're pretty much in sync. It's not the case that if you're going to do compliance with one, you can't do it with the other. But there are some differences in the timelines on when one goes into effect and versus the other. And that's where working together and having industry involved has really helped get this thing worked out a lot better than it was at one point.
And JIDIC will no longer be doing specific IPv6 testing. They have now rolled that into their normal acceptance criteria.
Yeah.
Thank you.
All right, thanks.
Perfect. Thank you very much. Oh, let's see. Moving right along. Adam. We haven't had a hosting provider, I don't think, today. Well,
I've not seen any in the room.
Yeah.
Hello, I'm Adam from Voxel.net. Just a quick backgrounder, and I'm going to skim through some of the earlier slides. We are a hosting provider. We are not content per se, though we have about 1,000 customers, most of which are some form of content. We are not a household name necessarily, though some of our customers who've agreed to let us use their logos in the slide are. And from a traffic perspective, we have a number of products. Our big ones are leasing of servers, either a physical or virtual machine. These are dual stack enabled today. And additionally, we have a CDN, which is not yet ready, but has many requisite building blocks in place. YV6, simply why not? No compelling reason we could think of. We wanted to provide our customers with ample time to get ready, test for possible reachability and application stack issues. And as Eric pointed out, V6 is not something generally common among hosters and something we would like to see change. For our deployment, I'm going to skim through this. It's a pretty simple topology we have in place, no real surprises, no real complexities. Richard Steenbergen and Aaron Hughes had Nanog talks which outline step by step exactly the process to follow and pretty much the deal there. Likewise, for our peering, there were no real gotchas to speak of. We simply enabled dual stack on our IX ports and P&Is where the counterparty wanted to. We maintain unique v4 and v6 peer groups and route maps so we can traffic engineer both of them differently. And in the IXs, one thing we found are that the route servers are our friends. They're not for everyone. We realize why some people are reluctant to use them. In fact, in some of the Equinix locations, we were pretty much the first network to actually connect and advertise a prefix to the route servers. But at the same time, we like them. They help with a lot of these slow start issues, just basically contacting peers, getting sessions up, that sort of thing. And over time, we're hoping to replace them with direct sessions. For our transit, it was also a pretty simple process. Basically, as our contracts came up for renewal with various vendors, we simply gave them the ultimatum: give us dual stack in all locations and don't charge extra for it. Most vendors were happy to comply. Actually, kudos to Level 3 and Telia specifically for being very much with it and cooperative on this point. Those who weren't, we terminated. And interesting side note that actually coincided with, thank you, failure in a number of areas. Actually, looking at the people who would not give us dual stack, we found they were also missing BGP black hole, missing support for IRR prefix list generation, missing a robust community set, delivering ports really slowly, treating 10 gig ports as if they were somehow gold plated and took many months to procure, had dated pricing and or commit models, and in the end, from a reachability perspective, we're very glad we issued this ultimatum and kind of regretted not doing it sooner. And just a little backgrounder on our boarding process when someone signs up for a server. Basically, right now, dual stack on a server is something which does not come standard. It requires an email to us, frankly, because we want to know who our users are, engage them, get a dialogue going, see what they're doing, why they want to adapt v6, so on and so forth. In the future, this will probably be a standard config. So just a screenshot of our internal system. It's very easy to board a customer. We basically have a GUI which we use, which will auto-assign them a 64 in their VLAN interface. Just punch in requirements, it'll give us a recommended net block, we click save, and at that point, basically our routers are automatically configured with this /64 on the customer's VLAN interface, and internally it's actually really simple to implement. We had the foresight basically from the get-go to database all IP addresses, be them v4 or v6 as 128-bit. And here's another screenshot. This is actually of our Adobe Air desktop app. As you can see, basically customers can spin up or spin down infrastructure themselves, be it a physical server or a virtual server, and lo and behold, if their account is flagged to support it, they will receive dual stack. Likewise, DNS, we are using Power DNS with a MySQL backend. This is a homegrown tool which is accessible to our customers and our staff. You can see it's simple to add a IPv6 reverse record. You can add quad A's. No real surprises there. As for deployment, by and large, it went well. Our internal tools are working well. Backbone deployment went well, no real issues. Data center and edge was a little bit hairier, just on these small top-of-rack Layer 3 devices required some reboots for TCAM carving. Even still, some of the CAM profiles that vendors give us are less than ideal, but work. One unexpected gotcha, a specific vendor platform seemed to suffer from an utter lack of QA. Basically, it supported v6 addressing, v4 BGP, but not v6 BGP. Try to establish a v6 BGP session, Voxel malloc. And as for our CDN, that's pretty much what we have to go. Underlying infrastructure is there, it needs additional QA, need to figure out logging and potential for breakage with our login. And one big thing, and something I really want to speak to in closing, is just the fear, uncertainty, and doubt. There are non-reachability scenarios that were discussed today. They're real. People learning an RA but not actually able to talk to the v6 internet, people with really dodgy or broken v6 connectivity, and at the end of the day, when we're serving the kind of traffic we are, a fraction of a percent still represents a lot of eyeballs, and at the end of the day, we are in business to deliver content, so that kind of gets in the way of things. Some next steps. Host addressing. Currently, we're basically just assigning a 64 per customer VLAN interface in effect. Common practice, but at the same time, seems a little bit gratuitous, also conducive to possible DDoS and port scanning scenarios. And when we roll out new services with a layer 3 hypervisor, you basically have sometimes a hypervisor functioning as a router and a single host. And do you really need a /64 for that? I'm not sure. I certainly hope not. And as for next steps, reachability testing, obviously we need more empirical data. To that end, with cooperation of certain customers, we are embedding certain objects, be it JavaScript, JPEG, or Flash, in customer websites to basically feel out for reachability. In addition, we're contacting specific peers and other eyeball networks of interest, basically trying to vet and qualify them. And just in closing, one thing we would really like to see is better community knowledge on the reachability scenarios. And to that end, I saw a lot of possible lightning talks and other comments left for various whitelisting services and reachability studies underway. If anyone could benefit from some VMs or physical machines on our network, we are more than willing to kick in, so please see me offline. And any questions?
Bravo. You had a little slide with interesting icons of some of your customers earlier. Don't go back.
Okay.
Just want to know if there's any correlation between those and people who've signed up for your IPv6.
There has been some. I can't speak to specifics. It's not been a lot, unfortunately, but we are looking to do specific case studies with some of these more name brand kind of customers, and hopefully come next NANUG or next conference, I'll have some actual facts and data to share there.
Okay, thanks.
Hi, Stan Barber. Have you had any customers, or is there any correlation between domestic and international customers with interest in IPv6?
It seems to really run the whole gamut. We've had comparable interest from domestically and abroad. Additionally, we have data centers in other continents, and people in the US are spinning up machines there, and vice versa. So interest has been pretty widespread, no real correlation.
Thank you very much.
Any other questions? No.
Great. Thank you, Adam. So go ahead. Suresh. Suresh Krishnan from Ericsson.
You want this? No, I'm okay. It's good. Hi, my name is Suresh. I'm here to talk about what kind of difficulties you can expect when you try to inspect packets in v6. So this is not a very popular topic. Like, people don't believe in middle boxes, but The fact is they exist, and they actually need to look at packets. So anybody who turned on an ACL on your router, you are looking at packets, okay? And I just want to like bring up like few points like where routers have had difficulties in the past, and they probably still do. It really depends on the architecture, but I just want to show what the flashpoints are. So, okay, in V6, a lot of the optional information, which was like in the extended part of the IP header, is like pushed into separate extension headers. Okay, and for example, like a fragment was like we had like a fragment ID and like the bits like for fragmentation, these are all being pushed into an extension header. So this makes standard packet processing much easier because you have a fixed length header and you don't have to worry about that. But if you have exception packets, it becomes much harder to process them. And there's like multiple extension headers, and there are variable number of them, and each of them can have variable lengths. Okay. And the extension header format is not very well defined. So each extension header can have like a different format. And this means that once you build your box, if a new kind of extension header gets defined, you're not going to be able to process the header, or you're not going to even be able to skip past the header to look further in the packet. Okay. So if you want to find out, let's say, if you want to do an ACL based on a TCP port, you actually need to skip through each of the headers in each of the middle boxes. Okay, so you have a router and you say like IP, ACL, blah, 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 port, destination port, whatever, 80. Then the router needs to skip through each of these headers to find the TCP port somewhere. So until it finds the TCP header. Okay, and this becomes difficult. If you have a software-based router, if you have Linux box doing this, it doesn't make much of a difference. Okay, because like it's just software, you keep doing it. But if you have like ASIC-based router, what happens is this packet gets pushed into a much slower path, and you're going to really lose a lot of throughput when this happens. Okay. And this is other thing called hop-by-hop options, like spelled EVIL. But like there's this other extension header which can have multiple options sitting in there, and the number of these options is not constrained. You can have like as many options as you want, and every router along the path or every box that's looking at them need to process them, even though it understands none of them. Okay, so this is like a surefire way of like doing a DDoS, like, or even a DOS on like a whole path. You just send one packet, and every router along the path is like going to think for a lot of time with these things. And so usually what happens is if some router doesn't understand it, just like throws out an error, and then your attack stops. But in this case, like there's a set of options that are defined that keep processing the rest of the options. So you could put like a bunch of options in there. None of the routers understand it, but they all keep forwarding it along the path. Okay, and you need to keep doing this for every packet. Okay, so this really means that you can have indeterminate amount of time trying to find like a transport port in the packet. Okay, and this could be like typically like even 10 times like the normal processing time to find a transport port. And there's like a bunch of things called like router alert, which means that this is a magic packet that anybody can send, which makes every router take like a closer look at the packet, which means that it's not like you can rate limit it, right? That's about it. Like, but it makes every router look inside the packet to see what's important to it. Okay. Other stuff is like we have tunneling. So a lot of the migration mechanisms require tunneling. For like people talked about 6RD, like 624, all these things are based on tunneling. And there's Teredo as well that's based on tunneling. All these things mean that you need to do the inspection based on the inner packet. But a lot of the routers, like there's a lot of router vendors here. The ACL support for like inner packets is very, very rare. Okay, it's very hard to do. I just want to show you like for Teredo. Okay, this is the heuristic that you need to run to actually find out if the packet is a Teredo packet, okay? And then you need to do the inspection after. So you can see it's like stuff is not really very trivial to do. So I just like want to point this out to people who are implementing these things to actually take care, okay? And that's about it. So if your routers are based on ASICs, be careful like what is like fixed and what's not fixed, so you can adapt to these things.
Thank you. Thank you. Is Bob here? Bob? Oh, yeah, that's true. Yeah, Oh, Vincent. Should have been more specific.
Sweet. Thanks. No, so I'm Bob Van Zant. I work for Cisco in the Security Technology Business Unit. I work on this product called the Email Security Appliance. A lot of you guys, your email probably goes through it. You might just not know it. We do spam and virus filtering. So what I wanted to talk to you guys about today is how we managed to get v6 into our product. All of you have probably heard this. There's no point. Why would we ever want to do IPv6? There's no customers asking for it. Sorry, you guys aren't calling us often enough. No customers means no revenue, means no project. So we had to invent a business case. We had to invent a way, pitch this to management to let us work on it. And so we came up with a couple of different things. These three high-level stuff. Training, we've heard quite a bit about today, where folks are like, nobody knows how to do v6, so we've got to find a way. How do we train them? And of course, the best way is experience. So developers, the engineers working on this thing, how are they going to get experience working with v6? They go read a book. That's not very much fun. What if we let them work on some code? Sweet. There's a handful of them that want to do it. Let them go at it. Operations and IT, it's the same thing. You know, Google, we've got Eric and Lorenzo here, and that's kind of how this stuff comes out. They want to work on it. Give them that opportunity. Customer support, the same thing. You pick up the phone, you guys call them up, hey, I got your new v6 product. I have this problem. And they don't know anything. What's IPv6? That's not a good thing for us. And so if you kind of look down at the bottom here, we planned to stumble. It's the year 2010. v6 is, come on, this conference isn't that big. v6 is picking up, but it's not that big. If we stumble now, customer support picks up the phone and says, what's v6? That might be okay. 2012, not so cool. And so we're planning to do that now. That was part of our pitch. Get v6 out there now in a limited early field trials and see what happens.
Can I ask us
Sure.
one question? So
Yeah.
we just heard about all these FAR government requirements.
Yes.
Isn't that enough, the justification you want to sell to the government?
You know, it depends on who you talk to. If you talk to product marketing, and I think even the gentleman that was talking about it says, it's a checkbox feature, and each of the departments is going to figure out what that means to them. So there's requirements, and there's checkboxes, and there are lots of different ways to check a checkbox. And so, I mean, you give a funny look, and trust me, I give the same look to the PM when they tell me this. There are lots of different ways to sell into those things without actually meeting all the requirements. And I'm sorry, but that's actually how it works. So we're going to, basically, especially with these types of devices, if you're a router, you got to be able to route v6. Okay, that's kind of like a real requirement. And on the security devices, it gets a little bit more tricky. I know I feel the same exact way, but this is what I get. And one other piece of our sales pitch is our product really does rely on data from our customers. We put these email appliances out into the field. We get data about IP addresses. This IP sent this many pieces of spam. This other IP spent a whole bunch of ham. And we can assign reputation to IPs. Well, we kind of built a business around that. And so for IPv6, we've got to start collecting that data. We've got to start figuring out who's sending the spam, who's spending the ham, build the reputation service so that in 2012, when everybody really starts banging down the door for v6 email, we're ready. We've got a real good service for them. And so what I would recommend, and the way we managed to pull this in, is kind of as a skunkworks project, similar to the 20% stuff we hear about at Google all the time. We're going to do this under the covers. We're not going to tell product marketing that we're spending engineering time on it. And we're going to make something happen. Feature parity, sorry. It took us, 8 or 9 years to get our product where it is today. We're not going to get their v6 feature parity that quickly. Pick a couple features. What's important? What do we think is most important? Enable it for v6, rinse and repeat. And so we're kind of at the first stage now, early field trials. This is what we call it within Cisco. And here you go. Here's an example of the first thing there is showing you that I configured interfaces with v6 addresses. Sweet. And the second one there is showing actual v6 email coming in through our appliance. How much email is over v6? Everybody's favorite slide. Not a whole lot. The big, huge bar at the top is our reputation system working great for v4 and blocking a whole lot of connections. Way down there, IPv6. Including those blacklisted connections, about 1.5%. So the current state, it's in early field trials. This morning, I'm really happy to announce that actually we have hosted email where we put our appliances in our data center and you guys rent them from us. That's actually went live over v6 this morning, just in time for this conference, of course, which is kind of cool. And then, of course, we're trying to apply this model. Yeah. Wahoo! We're trying to extend this model to other areas within Cisco. We managed to pull this off for the email security appliance. How can we apply it to the other areas within the company? We're getting customer feedback. We're shaping the product or shaping the rinse and repeat stage. And of course, we're waiting for more IPv6 email. So Gmail, SMTP, Yahoo, SMTP, Comcast. We're looking for you guys now as well.
Great. Yep.
Does the Cisco mail server actually already accept IPv6? Because last time I checked, it didn't.
No, you're right, and we could talk a lot about that. No, Cisco was actually one of IronPort's first large customers. So we do eat some of our own dog food, but we don't tend to involve ourselves in beta or early field trials enough. But trust me, they'll be hearing from us a lot. We really want that.
I got a question about the reputational list.
Yes.
How are you going to do those in V6? I mean, a
Right.
spammer could randomize the source.
Absolutely. We're absolutely thinking about that now. The service doesn't exist today because there's no data. We don't know who's sending spam. We don't know who's sending ham. We can't build it. But the obvious thing is there's no database that I can think of that can have 2 to the 128 rows in it. That's a lot of rows. So that's not going to exist anytime soon. And so we're thinking about how we're going to store that data. How are we going to aggregate stuff? So yeah, if everybody's getting a 64 and if free is handing out /60s, maybe we don't store reputation on a /128. Today we store them on /32. It's no big deal. 4 billion rows in the database. It's not a big deal. It's not going to scale for V6. We have to aggregate. We have to find other ways of doing reputation for those addresses. And we're working on it.
Thank you.
Thanks, guys.
Thank you. I think I'm going to change things up a bit here. So, Ed, if you want to pop up here in a second, I need to load up the new presentations real quick. We have wrong one. Yes, I have one other one I need to put in next. Sorry about that. Yes. Ed.
I'll do this. Hello, everyone. My name is Ed Horley. I was recently appointed the co-chair for the California IPv6 Task Force. We are going through a relaunch, and I wanted to quickly cover some items. So I wanted to talk about what we do, which is basically advocacy and education. How do we support that? And basically, it's by coordinating events that are going to be in California, specifically around IPv6. And then how do you get involved? And obviously we have a website URL, Twitter feed, and George Usi, who probably many of you are familiar with, that I spoke to this morning, unfortunately couldn't make it down here. He just wanted to quickly pitch in for that. The reason we're relaunching is because most of the folks who were originally involved with the California IPv6 Task Force all got usurped to work on the North American one, and we didn't have a lot of resources in California to run this anymore. We are breaking down, so many of you folks probably attended the Rocky Mountain IPv6 Task Force event. We are planning on hosting similar sort of events in California. California is a large enough region to be doing this stuff on our own. In fact, we will be breaking down into geographic regions, so I'm going to be running the Bay Area. George is going to be running Sacramento. We're looking for folks who want to run LA and San Diego, because we think there's going to be enough interest to be spreading out geographically across California. Please come see me. I'll be happy to hand you my business card, or you can get a hold of me via this way. Don't plan to stand between you and beer tonight, so that's it.
Thank you. Thanks, Ed. So I think we're down to the final two. Thank you all for hanging in there. Andre, do you want to come up here? Andre Broido, come on. Has recently started to do some analysis, actually, of some of our V6 things.
Yeah, so this is analysis that I have done tonight. So if some of the needs of the details are not right, that will, of course, make me blush later, but I still decided to show you some of the results. So I collected the IPv6 addresses that we saw in 2010, in the first 5 months of 2010, and then computed the number of subnets at each level of resolution, so chopping off the bits from the end of IP address and counting how many subnets we see. And I also compared it with IPv4 data that we had for 2 weeks in March. And here is what we get. This is the graph that shows how many subnets we see at each of the subnet length mask. For IPv4, you can see that this green line goes up like a straight line. This is because it is a logarithmic scale. So what you see is actually an exponential function with a factor of about 1.85. There is normally, if the IP space would be packed absolutely densely, so there would be every IP address would be used, you would see an exponential function with a factor of 2, which means that every next bit gives you twice as many subnets. In a normal IPv4 space, we have about 1.85 at the moment. And in IPv6 space, as you see, the most of the growth actually happens between the mask length of 12 and 48. And then there is the next interval where the growth happens between mask lengths of 64 and 80. By 80 bits, essentially, IP addresses become unique. Yeah. You can see it in a little bit greater detail on this other plot that is essentially the derivative of the plot I just have shown you. So here you see the green line tipping down at /15 and /23 resolution for IPv4. And then these two areas where the factors become really high, but they never reach the level of IPv4. The highest factor is about 1.71. Whereas, as I said, for IPv4, it is about 1.85, and it is about 1.8 at 15 and at 24 resolution, which you can intuitively think of as people, say, getting a /23 and saving half of it for future growth and using only half of it for current addressing. Like that. Yeah. Thanks.
And Yves Poppe had the honor of, or well, I don't know about honor, but did me the honor of closing out the last Tech Talk session at our last conference. So, whoops. Maybe if I had pointer skills. Yves? Thank you. What did you?
Thanks. Oh, that's fine. I'll use that.
Okay.
Thank you. So let's conclude. So congruence, in fact, the only one who talked about congruence was Eric. When I talk congruence, I'm talking about quality of service. I want to have the same experience if I do v4 or v6, because in fact I do not care really if I do v4 or v6. One thing we have seen today is that Lorenzo didn't talk about round-trip delay the way he did last year. That was a major problem, and the culprit, of course, was the use of inter-AS tunnels, the evil tunnels. So basically, thank you, Google, thank you, YouTube, for generating a lot of traffic that allowed me to grow that network by 60% and buy new expensive Cisco cards and things like that. And basically, that network nowadays runs about 9% of the world's internet traffic and growing. Latest routers added were Dar es Salaam, Moscow, and Cape Town, all dual stack, of course. Now, if we look at it last year, 2009 data, we were still much lower, and right now, end of the year 25, and the latest stats were up to 32% dual stack. Why is that? Is that we changed our incentive for our salespeople. We told them, tell our customers to go dual stack. Now, basically, our customers are about 500 ASs. We don't have end users. So salespeople said, I am not interested to sell dual stack because I have to go back to the customer. There's no additional revenue for V6. So basically, why should I bother? And there is another sales order to implement. So the change we made, if a customer renews, and basically a customer order is on average 1 year, if he renews, by default, he gets dual stack. Only if he says, I only need V4, does he get V4. So basically, that solved that problem. again, people don't care about v6. If you go and tell them do you want v6, you will get the question why or what is that. So basically, I would recommend to everyone in the space, including our content providers, don't go and tell customers, do you need v6? You will wait till the last minute. You tell your management, my revenue is Sigma v4 plus v6, and if you give me v4 and v6, my revenue stream is guaranteed. I will have business continuity, and I will be independent of the variable of the transition speed. Some recent metrics, we know them. We reached 3,000 active entries and growing. This is still not big, but is healthy. And if we go forward, I think congruence is much closer than it was a year ago. In fact, in March in Bahrain at the Cisco networkers, we activated v6 there KK was there for Google. And I think, Gunther, correct me if I'm wrong, about 700 people connected in v6. The vast majority didn't know they connected in v6 and they could not have cared. But this is healthy. Now, missing the grade, CPE equipment vendors. I was in the market by chance for a new little box, and it was between Dlink and Linksys. Now, you know what I bought. Because... And again, there's one thing to say every year, I'm committed to IPv6. There's a difference between commitment and going to the altar to get married. So the other part missing is load balancing. There is still a lot of load balancing missing. I need content because I was told by management you spend 1/3 of your time on IPv6. It only generates 1% of the traffic. If you want to get your bonus next year, it should generate 10% of the traffic. So, Mr. Content Providers, get working so I get my bonus. Thank you.
Thank you, Yves.